Good morning, ladies and gentlemen. Today we're going to look at graphing cubics. Now, graphing cubics is very similar in many ways to graphing quadratics and shares similar properties with graphing quartics. Essentially, if you've nailed quadratics, you'll notice lots of patterns with cubics and quartics, and the rest become easier. Alright, so here, one thing they do differ in is the end behavior. Now, cubics will either do that or this, depending on whether A has a value that's greater than 0 or less than 0. Every cubic polynomial must cut the x-axis at least once and therefore has at least one real root. Alright, cubics in any form can look like this. A, alpha, beta, that fellow there is gamma. So note that A here determines the shape. We could easily cut the axes 3 times like that if A was negative or less than 0. That's meant to be a less than sign. Then it would look like that. So here, note that a repeated function with a squared will have it touching at x equals A. Finally, we can have the form a cubed function where the point of inflection, or where it's temporarily horizontal, occurs at the x-axis. It's like a triple repeated root. So it's like what we have with quadratics, where it's touching, but this time it feels like it's touching 3 times because it flattens off entirely there. Here, if we have a cubic that only cuts once, then it's made up of a cubic, cutting there, and then this quadratic, because the quadratic doesn't produce any roots, we know that the discriminant of that quadratic is less than 0, which is what it says there in the notes. Alright, now, a couple of questions. Use axis-intercepts to sketch the graph of. To get an axis-intercept, here in A, we have axis-intercepts of x-intercepts of -4, -1, and 2, and the y-intercept you get when you let x equal 0. So if we're letting the x equal 0 here, we basically just get rid of it from there, there, and there. Note how I've kept the sign. Positive 4 times positive 1 times negative 2 is negative 8. So we're going at a graph that's going to cross down here at -8. We're cutting at -4, we're cutting at -1, and we're cutting at 2. So we want some sort of graph that cuts all of them, and you know how the leading coefficient is positive? Leading coefficient is positive means the overall direction is that way. So we're going to start from down here, we're up, turning, cutting, turning, like that. Note that I don't have to turn exactly on the -8, I've just drawn it poorly. Now, this here could look different. Let's look at cubics. This here will cut at x equals -2. And because it's repeated 3 times, it's actually going to level off there. Heading up. And it'll cross here at 8. Because if we let x equals 0, 2 to the power of 3 is 8. Crossing at 8. Use the same terrible graph to do this one here. This one here will be negative, so coming down like this. Crossing at -2 again. In fact, touching at -2. And crossing at, that'll be 3 on 2. So positive 3 on 2 is out here. And we're going to come down. We're going to touch. We're going to come up. And we're going to go down again. And we're finding out, well, how far do we go up? Well, if x is 0, this is 4. If x is 0, that is -3. 4 times -3 is -12. But careful, that's hanging out the front. It comes out here to rub that off. We're going to cut up here at 12. Alright, I apologize that's messy, but I'm trying to make the video not too long. Okay, find the equation of the cubic with the graph below. So the equation of the cubic, we've chosen a couple of easy ones to start with, is a matter of remembering the forms. So the forms are here, cutting 3 times, touching once, cutting only once, and touching like a triple repeated root, and here, single root, quadratic. That one is the hardest to find in terms of graphs. We've gone with the 2 easiest. So start with the form y equals a bracket x take alpha, x take beta, x take gamma, and then we sub in all the values. So here we have a, x plus 1, x take 2, and x take 3. Then we need to find a by using this final point here, just like we did with quadratics. Alright, I'm actually going to skip this last one because we're going to keep the video under 5 minutes. How good is that? Alright, cheers, bye.